So today we are going to start with this chapter log. Have you studied this chapter before or gone through this? Any idea about what logs are? Okay. So in the previous classes we studied about pH, right? And we have also seen the formula for decibel or sound intensity, right? For example, pH was minus of log of H plus. And if you look at the intensity of sound, it is say 10 log I upon I. So, I mean, if you have not seen it till now, maybe in future you'll come across these. So, I mean, some of the places, for example, when you are computing pH of any solution, right? So, it is in terms of log. So, you have to use log. When you are measuring the intensity of sound, you have to use log, right? So, where do we basically use logs? Wherein we have numbers or very large numbers that has high powers. For example, if you look at H plus, so hydrogen ion concentration is of the form say 10 to the power minus 12, 10 to the power minus 10, like this. Although the power is negative, but still it is higher, right? So very high or very low numbers or something that involves large powers. So then we apply this log. So, and the application of log is that it makes the calculation more simpler. Okay. So the log of a number n to a base a. So there are two components of log. So you have log, which is the function, right? Then you have this. So this is known as the argument, the number n, right? And then you have this base. This is known as base. So there are three components. One is the log, which is the function, n is the argument or the number, and a is the base, right? So let us say if this is x, right? So now what is the definition of log? The log of a number n to a base a. So this is the number n to a base a is an exponent. Exponent, we know, we have studied powers and exponents, right? So exponents represents power, right? So it is an exponent indicating the power to which the base a must be raised to obtain the number n. So this means if this is x, right? So log of n to the base a means that you should raise a to the power x. So if you raise a to the power x, you'll get n. Yeah. Okay, so you are trying to find the power to which you raise a number so that you get the given number. So this is the base, right? And this is the exponent. So this log is basically the exponent. Okay, so for example, if you have log of 10,000 or say 1,000 and the base is 10, right? Can you tell me the value that you may get? So what does this mean? This means exponent, right? So this means that what power should you raise 10 to so that you get 1,000? No. This means if you multiply 10 with 100, you'll get 1,000. Right? So 10 to the power what is 1,000? So this is what we try to answer when we are using logs. 10 cube is 1,000. Right? So 10 times 10 times 10 is 1,000. So this will be equal to 3. So when I am given a number, right, and a base, so the log of that thing will be equal to what number should I raise the base to so that I get this. Okay, is this clear? So this is what the definition says. The log of a number n to a base a is an exponent indicating the power to which the base a must be raised to obtain the number n. So if you solve this, you'll get the power or the exponent, right? So log is basically this thing. this x, right? This number is designated as log n to the base a, right? So we read it like this. So log, then the number, not the base. So first we read log n to the base a, right? So this is how we read any given log. Here n is usually called argument of the log and a is called base of the log. So n is the argument or the number and a is the base. Yeah. A is the number that must be raised to a certain power. Power is this value. This value is power, right? So whenever you see log, just think of this equation, a to the power x equals to n. So this is log, right? So log n to the base a is equal to x. So you are assuming that let this be equal to x, which means that a to the power x must be n. Right? How we think of this is just take this here. When we take this to the right hand side, because you know that log is opposite of exponent. So when you solve for both the sides, so this is just like addition and subtraction. So then we have to flip it. Right? Addition becomes subtraction, subtraction becomes addition, multiplication becomes division, division becomes multiplication. Similarly, log becomes exponent. Right? So if this is given x, so this means this power is x. That means I must raise a to the power x. So if I raise a to the power x, I'll get n. Right? Is this clear? Yeah, so I mean, it will take some time for you to get familiar with this. So you have to keep on. So whenever you get any number, you have to keep on thinking that thing. So then it will become more clear to you. Okay, and this is a very important topic because every topic that you'll see in your higher classes, you'll have a question on log. So be it physics, be it chemistry, be it mathematics, so everything has log in it. Okay. So by the definition of log, okay, we have to discuss this. So here there are certain constraints. We have studied about domain and range, right? What is the difference between them? What is the difference between a domain and a range? So when you are given y is equal to f of x, f can be any function, right? It can be a polynomial, it can be even a log, it can be modulus, anything, right? So there are only specific values. For example, if y is 1 upon 1 minus x, right? So there are certain values, so you cannot write x can be anything or any real number. There are certain values for which you'll not be able to solve this, so you have to exclude that. Right, so that means x belongs to R minus 1. So because we will not be able to get the value when x is equal to 1. Y means all the possible values of y that you'll get. So you can check by substituting. So when x is 0, it will be 1. When x is 2, x is 3, x is 4, x is 5. So you can see that y will be all possible real number. So domain means set of values that this can take. Range means set of values that it produces or the output that it will give. Okay, so we are currently talking about the domain only, or what are the possible values that it can take. Right, the first constraint is that a must be greater than 0. So this a, what is a? This is the number that is raised to a certain power. Right, so this must be greater than 0. And this also must be not equal to 1. No, it can be a fraction. So first of all, tell me why we are considering this. Why is a greater than 0? The square of negative number won't be iota, it will be positive. Yeah, you are on the correct track. So because we'll get complex numbers. So for example, you have log n and then base is a is equal to x, right? So the first case we'll discuss, n is greater than 0. Let us start by this. So n is greater than 0, right? So you have ax equals to n. So a to the power x is equal to n. What if n was less than 0? Yeah, right. And because you have this condition n greater than 0, so that automatically makes a should also be greater than 0, right? So say let us take a as negative. So when a is negative and x is a fraction, then it will be an imaginary number, right? And that automatically, so when a is greater than 0, so we can prove that a should always be greater than 0. A should not be less than or equal to 0. Why? When this is a fraction, then it will lead to imaginary number. For 0, I mean, when a is 0, there is only one possible solution, which is n should also be 0. So that is why we exclude that, right? Then if a is greater than 0, so any power of x, I mean, any power of a should also be greater than 0, which is equal to n, right? So n should also be greater than 0. Now, why is a not equal to 1? So that means 1 to the power x is equal to n, right? 1 to the power anything is 1 itself, but n can have any value because n is a number, right? You know n is greater than 0, but left hand side is always 1. So this does not make sense. So that is why we exclude 1 as well. Okay. So the first thing is a should be greater than 0. The second thing is a should not be equal to 1. Third thing is n should be greater than 0. Right. So this is greater than 0 and this is greater than 0 and this is not equal to 1. Okay. Now see, you have some examples. So 2 to the power 4 is 16. Right. 2 to the power 4 is 16. So what is the value of log of 16 base 2? 4. Because what power should I raise 2 by so that I'll get 16? It is 4. So 2 to the power 4 is 16. So this is giving you the exponent, the value of the exponent, right? Then you have certain examples. 3 to the power 5 is 243. So what is log of 243 base 3? It is 5. 5 to the power 4 is 625. So what is log 625 base 5? Yeah. Similarly, you can have negatives as well. So see here, neither n is negative nor a is negative. What is negative? Log is negative. The value of the log is negative. So log, so now we are talking about range and not domain. Range means what value that log will give us. So you know exponents can be negative as well as positive, right? So it can take any value. So y belongs to R, and for x you have these conditions, right? So here it is saying 2 to the power minus 3 is 1 upon 8. So we'll write what is, so n is this, right? So 1 upon 8 base 2, this is equal to minus 3, right? And then you have 7 to the power 0 is equal to 1. So log of 1 base 7 is equal to 0. What is log of 10, sorry, 1 base 10? What is the value of this? No. So what question should you ask yourself? what power should I raise 10 by so that I get 1? No. So see, 10 to the power 1 upon 10, what is the value? This is the 10th root of 10. It is not equal to 1. Okay, so ask yourself this question. So 10 to the power question mark. This is what we find is equal to 1. Minus? No. 10 to the power minus 1 will be 1 upon 10. So in base and exponents, we had studied this, right? A to the power 0 is 1. Anything to the power 0 is 1. So can we write 0 here? 10 to the power 0 is 1. Right? Is this clear? So this should be 0. So what power should I raise 10 by so that I'll get 1? It will be 0. So that means you'll get a theorem from here. So log of 1 based base A. So A can be anything. No matter what A is, it will be 0. This is the opposite of what we studied. Right? In base and exponents, we studied A to the power 0 is 1. Here we are studying the opposite. So this is the number n. So whenever you see this, remember the notation. This is n, this is base, and this is the answer or x. Right? So you have to relate this to the equation. Any question? Okay. So in general, the expression log n to the base a is meaningful if and only if a greater than 0, a is not equal to 1 and n greater than 0. Right? This we have already discussed why. The existence and uniqueness of the number follows from the properties of exponential functions. So it has the same properties that we discussed in exponential function, only there's some switching of the values here and there. Right? Now what kind of questions we can get? If log m to the base 4 is 1.5, so log m to the base 4 is 1.5. Find the value of m. Right, so what you do, you just take this to the right hand side and it will come as the base because this is base, right? So this is base, so if you take this to the right hand side, it will be base like this 4 and this will be exponent. So if you want to remove log, you take that is known as anti-log. Okay, so what happens is that 4 will go on the right hand side, so log will vanish. So m will be equal to 4 to the power 1.5. Right? So m is equal to 4 to the power 3 upon 2. So this is 2 square, right? Which is equal to 8. Right? So try solving this. If log m upon 25, so this is base, m to the base 25 is equal to 2.5. Or yeah, let this be 9 instead of 25. Can you find the value of m? No. So what power should you raise 9 to so that you get m? We get m. Yeah. So is the answer 2.5? No. So here you are already given the power that you have to raise, right?
Okay. So it will be 9 raised to 2.5.
Yeah. So m will be equal to 9 to the power 2.5.
So it's to 5 upon 2, right? So 9's root of 9, 3
Yeah.
into 9 raised to 5.
3. So you can write 9 as 3 square.
So it will be 3 raised to 5.
Yeah. So 3 square times 5.2.
Yeah, so 2, 2, 4.
So what is a to the power m to the power n? Yeah. So here also this is a to the power m to the power n. So this will be 3 to the power 2 times 5.2.
So
3 to the power 5. So what is the value of this? Yeah, so it will be 243 because 81 times 3, it will be 243, right?
yeah.
Okay. Then say for example you have log m 125 is equal to 2 upon 3. Can you find the value of m?
So 20.
M is 25.
Yeah.
Okay. So, I mean, what did you do?
So,
Yeah.
so root of 125 is 5. 5 square is 20.
Yeah. Yeah. So you'll write 5 to the power 3 multiplied by 2 upon 3. So it will be 5 square and then 25. Right. Can you find the value of this? Yeah. So we should raise 3 to the power 4 to get 81. The question is asking 3 to the power x. So how do you solve this? Assume this is x. Now you'll get 3 to the power x is equal to 81. Then you'll get 3 to the power x is equal to 3 to the power 4. X is equal to 4. Right? Then you have this question, if log p to the base 5 is a and log q to the base 2 is a, right? Both are a, then prove that p to the power 4, q to the power 4 upon 100 is equal to 100 times 2a minus 1. Can you try solving this once? I'll tell you how you should solve this. First, find the value of p in terms of a. Then find the value of q in terms of a. Right? So once you do that, you'll get rid of that log. Right? And then you'll be just left with p in terms of a and q in terms of a, which you can solve to get this thing.
P equal to a raised to 5.
Yeah, p is a to the power 5 or 5 to the power a, right?
Yeah, 5.
Yeah.
So if we put that value in p raised to 4 upon into q raised to 4 upon
Yeah, maybe you can first find the value of p to the power 4. Before substituting, try finding the value of p to the power 4.
5 raised to 4n.
Yeah. What about q to the power 4?
2 raised to 4.
2 raised to 4. Right, then p to the power 4 times q to the power 4.
Yeah, so power is same.
Yeah,
Power, so pq raised to 4.
yeah,
10 raised to 4.
very good. So 10 to the power 4, right? And this is also divided by 100, right? So now you get an idea that you have to write everything in terms of 100, right? Then how will you do that? Yeah. So if you write 100 as 10 square, but this will make your answer in terms of 10, not 100. You want your answer to be in terms of 100. So instead of making this in terms of 10, you have to make this in terms of 100. Is there a way to do that? Yeah, yeah, yeah. 100 to the power 2a upon 100, right? So which is equal to 100 to the power 2a minus 1. Okay, any doubt? Okay, see, why are we solving such questions? Because in future, whenever, so sometimes will be given, say, h is equal to 1, or say 2 into 10 to the power minus 36, right? Now, options will be given as, so you'll not be given find the value of h. Will be given, so I mean, say you got a question in physics, find the value of h, right? You did some calculation, got this value. So it will not be in the options will not have the value of h. It will have log of h. So log of h is equal to something, log of h is equal to something, 2 log of h is equal to this. So you'll get questions like this. Specifically for JEE advanced, when you have multiple answers correct, right? So sometimes you may be given h is equal to this, and the next option you'll have log of h is equal to this, right? So you have to find that value as well. Yeah. So, I mean, we have an assumption. So when we don't have any base, there are two universal bases that we have, 10 or E. So you must have seen these two, right? 10 to the power 23 or E to the power 20. So there are two, I mean, when you go to higher classes, so there will be two values or two logs that you'll have. One is log, and when you are not given any base, you assume base is 10. The other will be ln, which is also known as natural log, right? So when you have this natural log, the base is always E. So when it is mentioned as ln, it means log with a base E. So E is also a constant. The value is around 2.71. Okay, so sometimes power are represented in the form of 10 to the power 23. Sometimes power is represented in the form of E to the power something. So that is why these are the most common bases that we use. ln. No, ln, I mean, it is a function. So you apply it to a number. So you can apply it to this number.
So ln is always equal to log of E.
Yeah. So base is always E. And then the number is up to you. You can choose 2, you can choose 4, you can choose 10,000, 1,000,000, whatever. Okay. Similarly, this, when you are given just log, you assume the base is 10 and then find the log of that number. So n is up to you. And if you have anything other than this, you'll be specified the base. Okay. The value of n satisfying log a. So this is the number inside. This entire thing is inside this log a. Then you have 1 plus log b. Then this entire thing is inside. So 1 plus log c. Then this entire thing is inside. Plus 1 plus log n base p is equal to 0. So log of, say this is x or a number n. Right. So log of n to the base a is equal to 0. What can you say about n?
So n is always
Yeah. So that means the first observation is this thing is equal to 1, right? That is why this came out to be 0. So this is equal to 1. Now if you solve this, you get 1 plus log of something is equal to 1. 1 and 1 will be cancelled. So you'll again get log b of some number is 0. Which means this is again equal to 1. This thing. Right? If you solve that again, you'll get 1 and 1 will become again 0. So you'll get log c times 1 plus log n to the base p is 0. Right? So, sorry, this is 1. Right? So log of 1 plus log n to the base p is equal to 0, which means 1 plus log n to the base p is 1, which means,
log n to the base p should be 0.
yeah. So what is the value of n? Yeah, n is 1. What if it was log p to the base p? What is the value of this?
So it should be 1.
Yeah. So again, the same question. What should I have the in the exponent of p so that I get p? So p to the power x. So p to the power what is p? It should be 1. Right? Now see, currently we are calculating and we are able to calculate because the numbers are easy. Right? So they are perfect squares. Sometimes they are not. So for that we have tables given. So for example, log 2 or ln 2. So you can find the value of ln 2 from the table, log table. So when you are in your board exam, you get a log table as well. So that contains the values of logs. Right? Even when you are appearing for any JEE examination, you get log tables, right? Or the value of that log. Because you cannot remember the log. So there are certain logs that you can remember. So 2, 5. So since you'll use them frequently, you can remember them. But if you have different logs, say log 2.173, you'll be given the value of that.
So sir, log 2 means base.
2 is the number. Base, you'll always have here.
So
Yeah, so if it is not given, then you have to assume it as, so when it is given ln, you assume it is a e, and when it is not given, so you assume 10. Okay. So what should I raise, I mean, to the power of 10 so that I get 2? 2 log,
2 log 2 to the base 10. So it should be
it should be,
0.
no. So see this, the question is,
10 raised to x equals
yeah, so 10 raised to x is equal to 2. So what is the value of 10? Yeah, I mean value of x. Yeah, it is not possible. So you have to use log tables. So if you use log tables, the value will approximately come out to be 0.301. And you can calculate. So 10 to the power 0.301. You see, it is 1.99998. So if you round that off, it becomes close to 2. Right? So logs are helpful for such cases wherein we don't know or when we end up in such equations. So 5 to the power x is equal to 2. We cannot solve it using our traditional approach. Right? So what we do, we take log on both sides. So we want to find the value of x. So we take log on both sides. So we'll get log of 5 to the power x is equal to log of 2. Right? And then we'll study about a property that if you have log 5 to the power x, we can write x log 5.
So log 5 times x.
Yeah. So this becomes equal to log 5 times x. So this, whatever power you have inside the number, it gets multiplied with log.
And the base will always be 10.
Yeah. If you are not given anything, that it will be 10. We'll assume it as 10. Right? Most of the times you'll be specified with the base, but when you are not specified, when it is given log, you assume this as 10. When it is given ln, you assume that as e. Right? So the value of x will be log 2 upon log 5.
Yeah.
Right? Let me just search the value. Log 2, we already saw the value of log 2 was 0.301. Right? Then we have log 5. It is 0.6989. So if you just do a Google search, you'll be able to find. So what I'm searching for is log 5 base 10. Okay, so I'm searching for log 2 base 10. So if you search for it, you'll also end up in the same answer. So I have to specify the log of that number and the base as well to get the value. Okay. Is this clear, Puneet?
Yes.
Okay. So then what is the value of 0.301 upon 0.6989? So 0.301 upon 0.6989. So it is 0.4306. Now we'll just check is 5 to the power 0.4306 is equal to 2. Yeah, see, you are getting 1.9999 again. Right? So log helps us to solve such questions which we would not be able to solve otherwise. Right? And what is required? We need the, first of all, we need the understanding of log, and then we need the log tables, which has the values specified for log 2 and log 5. Okay, can you just do a quick search for the value of log 2 and see if you are getting the same result?
Log 2, right?
Yeah, log 2 and then base 10.
So it's 0.301.
Yeah, so 3010, right, which is 0.301 itself. This is what we have taken. And then what about log 5 to the base 10?
Log 5 is to base 10.
Yeah.
0.698.
Yeah. Right. Now can you check log 5 to the base e? Try finding the value of that. Is this equal?
So ln 5, right?
Yeah.
1.069. 60. 60.
1.60.
Yeah.
Right. So see, you are getting a different result. When you change the base, you get different results. When the base was 10, it was 0.69. When the base was E, which is 2.71. Now it is obvious the power must be greater than 1 because you want to get 5 from 2.71. That is why the power is greater than 1. And here the base was 10, you wanted to get a number less than 10, which is 5. So the power is less than 1.
Yeah.
Right. So because we have to take the root of 10, some root of 10 to get 5. However, we have to take some power of 2 to get 5, which is 1.6. So if you take 2.71 to the power 1.6, you'll get 5.
Yes.
Okay, any doubts?
No, sir.
Then we have some properties of log. So this we have already discussed, the first one.
Yeah.
If you have the argument is 1, no matter what the base is, it will always be 0. Okay, can you tell me the value of this?
1.
No.
So 1 raised to 1 is 1, right?
So that is where the confusion is, right? So this property says that no matter what the value of the base is, it will always end up in 0.
Yeah.
But here you have, when you have base as 1, this does not become 0, it becomes 1. So that is why when we are discussing the domain, we specify that this base cannot be 1, a is not equal to 1. That is where this is coming from.
Okay.
Right, because you know that 1 to the power 1 is 1 and 1 to the power 0 is also 1.
Yeah.
So that will make the log function ambiguous. So that is why we don't apply this when the base is 1. We say that when base is 1, we will not be applying log.
So just because of 1, we don't apply it for all the numbers, for everything.
With base 1, because I mean 1, if you take any power, you'll end up in 1. So it does not make sense to use it when we have the base as 1,
Yeah.
right?
Yes.
Because see, 1 applies or follows both these properties at the same time. So it is violating, right? Or you can consider that as an exception. So that is why we don't apply that function. Mathematics is not similar to physics wherein you can have exceptions. So when you have exceptions, you don't apply that function. So that function is no longer applicable,
Yeah.
right? So this one is one particular theorem, but you should note that a must not be equal to 1. Here log n to the base n is equal to 1. Here you'll write n is greater than 0, first case. Then the second case is base also must be greater than 0 and base must not be equal to 1,
Okay.
right?
Yes.
So that is what they have written, n greater than 0 and not equals to 1, because here n is the base as well. Okay. Then you have log n to the power to the base 1 upon n. So again, if you ask yourself this question, 1 upon n raised to what power gives you n?
Yeah. So minus 1.
Yeah. So x will be minus 1. So when the base is 1 upon n, or say when this is even 1 upon n, which means the reverse thing. So log of 1 upon n to the base n. This is also minus 1. Why? Because if you ask yourself, what should I raise n to the power what is equal to 1 upon n?
Yes.
This is again minus 1,
Yeah.
right? So this is the property. So log n to the base 1 upon n is equal to minus 1, and it is also equal to log 1 upon n to the base n, right?
Yes.
So these are few important properties, and then you have the identity of log. So this says a log n base a is equal to n. How is this true? So we are saying log n to the base a, right? So this is the definition. So let this be x, right?
Yes.
This is x. Now I say that this means that a to the power x is equal to n.
Yeah.
So instead of x, can I just substitute this?
Yes.
So if I substitute this, I get this identity. Is this clear? So we are just using the definition here.
Yes.
Okay. So this just means a to the power x is equal to n, where x is log n to the base a, right? Then you have few more properties. So this means log a mn is equal to log a m plus log a n. You can relate it with power, right? So when you are multiplying two numbers, their powers add up, right? Log is essentially power. So when you are multiplying two numbers, their powers just add up, right?
Yeah.
Similarly, when you divide two numbers, their powers are subtracted. So when we are writing log, it is essentially power. Right? So this is power, right? So these are powers. How can we relate this? So see, when we were studying powers and exponents, we studied that a to the power m plus a to the power n, sorry, multiplied by, is equal to a to the power m plus n, right?
Yes.
So what we are doing is we are essentially multiplying two numbers. This is what you mean by let this be m, let this be n. So we multiplied these two numbers and then check the power. So this is what you mean by, so we multiplied those two numbers and let the power be something, x. This is equal to the power of a, so the first number, so this is the power of the first number, right? Plus this is the power of the second number. So the power of their product is equal to the power sum of the power of the first number plus the power of the second number. Similarly, when we are dividing, so their difference, I mean the when we divide two numbers and then check the power of the division, so it is equal to, so we have to subtract the powers, right? And then this we have already seen,
Yes.
right? So again this applies this rule, a to the power n to the power n. So this is a to the power n. So powers are multiplied in such cases, right? So remember that this is power. So whenever you have this, this means power. Okay. So then you have a question, find the value of 2 log 2 upon 5 plus 3 log 25 upon 8 minus log 625 upon 128. Okay, so can you do log m plus log n is equal to log mn here?
Yeah.
See, this is not just log. So the formula said log m plus log n is equal to log mn. But it is 2 log m plus 3 log n. So what will you do? Will you write 2 log mn or 3 log mn? Or 6 log mn?
I guess 6.
No. So because this is outside,
Okay.
right? So you'll not apply that logic. First of all, you have to bring it such that you only have log,
Yeah.
right? So you have to get rid of this 2. Which of the following should you apply to get rid of this 2?
C.
Yeah, see, it is the opposite that you have to apply. So this means 2 log m to the base a. So when you have 2 log m to the base a, and if you want to get rid of this 2, you just raise this to the power x, right?
Yeah.
So you'll just write this as, remember that you are not given the base, so you don't need to write anything. So log 2 upon 5 whole square, right?
Yes.
Plus log 25 upon 8 to the power 6, right?
Yes.
Then minus log 625 upon 120. Now we can solve. So these two powers will be multiplied and then this will be divided, right? So 4 upon 25 multiplied by 25 to the power 6 upon 8 to the power 6, and then this is divided by 128 upon 625, right?
Yes.
Now we just have to solve for this. So this will become 25 to the power 5, and if you remove this 625, so 25 square is 625, right?
Yeah. So 25 is to 3.
Yeah, so 25 to the power 3.
Sir,
Yeah,
but that is in division, right? So we will inverse that. 128 upon 625.
yeah, so this is just multiplication. So because this was divided by 625 upon 128, right? So I just flipped it but forgot to change the sign,
Yes.
right? So you'll get then if you take out one of the 8, right? So that will be, so this will be 8 to the power 5, and then 2 will remain from that 8,
Yes.
right? Then 264, which is 8 square. So here you'll get 8 cube, right?
So 25 upon 8 cube.
Yeah, so 25 cube upon 8 cube, and this will be inside log, right?
Yeah.
So log of 25 upon 8 whole cube, right? And then you can write 3 log 25 upon 8,
Yes.
right? How come they are getting log 1? Did we do something wrong here? So 2 square upon 5 square, we did it correctly. Okay, instead of 6, it should have been 3, right? So 25 upon 8 to the power 3, not 6, right?
Yes.
Because it is 3 log 25 upon 8, so it will become log of 25 cube upon 8 cube, right?
Yes.
Okay, is this part clear?
Yes.
Now if we divide, then we'll get 1, because we ended up with 25 upon 8 cube, which was the extra part that we wrote, right? So I mean, maybe we can solve this again. So we'll get 4 upon 25. So this entire thing will be inside log. So log of 4 upon 25 multiplied by 25 cube upon 8 cube, and then multiplied by 128 upon 625. Right, that is it.
Yes.
So 25, this becomes square, and 25 square and 625 gets cancelled. Similarly 4, and then this becomes square, 1 2 remains, so 264, and then 8 square and 64 gets cancelled, so you get log of 1, which is 0,
Okay.
right?